Okay, we need to figure out what are the coordinates going to be for L prime, W prime, F prime, and M prime. So to do that, it's useful, and we're going to be dilating this by a factor of 1/2. And I should indicate that we're dilating in reference to a center of dilation at the origin. Okay, so the first thing to do, you can eyeball this sort of thing, but I'm going to do it mathematically. I'm going to start off by identifying what L, W, F, and M are as coordinates. So L is currently 1, -5. That's 1, -5. And W is 5, -5. And then F is 4, -2. And M is 3, -2. Okay. To dilate by 1/2 in reference to the origin, all you actually have to do is divide each coordinate by 2. So I'm going to be at L prime will be at 1/2, comma, -2.5. I realize I'm mixing fractions and decimals, so I'll make that a little clearer to keep it as decimals. Okay, and W prime is going to go from 5, -5 to 2.5, -2.5. And then F prime is going to go from F, which will be at 4, -2, to half of 4, which is 2, and half of -2, which is -1. And then M goes from 3, -2 to half of 3, 1.5, half of -2, -1 for M prime. So those are our points for L prime, W prime, F prime, and M prime. So let's go ahead and plot those. So L prime will be 1/2 -2.5, which will be right about there. Okay, that's L prime, and it's very unfortunate that this pin is marking so large like that, because it's going to be harder with this. W prime is going to be 2.5, -2.5. So there's L prime. Okay, I'm sorry, not L prime. Let me undo that last thing I just did. Erase. Make that a W prime. That's what I meant to say. So that's going to be W prime. Okay, because that's W prime. Now I'm going to have F prime. F prime is going to go from 4, -2 to 2, -1. So 2, -1, there's F prime. And then M prime is going to be half on the X and half on the Y. So M prime is going to be at 1.5, -1, which is right there. So that's M prime. And then I connect all my dots like that. And I have dilated that by 1/2. Okay. Interestingly enough, you could now draw lines that go from the origin right through that vertex to that vertex, right through this vertex to there, right through this vertex to there. And so all of these vertices end up lining up with the origin. Those are not the best drawn lines, but hopefully you get the idea. Let me go back here and... All right, cool. Now let's go on to the next one. So we want to write a rule of dilation from the black triangle RST to the blue one R prime S prime T prime. And what you want to do is you want to think, okay, how did each of these points change? From 0, -1 to 0, -2. So 0, can't really tell how it changed, but -1 got doubled to -2. Let's look at T. T is at -1, -1, and it went to -2, sorry, -1, +1, and it went to -2, +2. That's doubling of both coordinates. And r went from 2, 2 to 4, 4. So in each case, we have dilated it times 2. Dilation times 2 in reference to the origin. And that's what's happening. We've just doubled the x and y distances from the origin. So x went from 2 to 4, and y went from 2 to 4 as well. In each case, we've simply doubled things. Now, in reference to a center of dilation at the origin. We're going to come up with a rule for this dilation that is from the black triangle AKX to A prime K prime X prime. So again, we're going to look at these coordinates. Now it's a little trickier this time because we've got some stuff that is not quite on the grid, but if we focus just on the X, it'll help us. Okay, so let's focus on what K's X values is. K is, of course, at -4, -1. Okay, K prime is at -1, negative something. It looks like it could be -1/4, but it's definitely at -1 for x, which is times 1/4. So let's check that out for x. X is currently at -4, -3, and the x value became -1. So that's definitely a divide by 4 times 1/4. And if we looked at the y of 3 and we multiplied that times 1/4, we would end up at 3/4. That's a reasonable spot for 3/4. The y value of 1 for -1. So -3 goes to -3/4. Y value of -1 goes to -1/4. So let's take a look at this one. What would a 1/4 dilation do to a point at -2, -3? So -3 should end up at -3/4, so lined up with the x, and -2 should end up at 1/2. That does -1/2. That does look like -1/2, -3/4. So I think we can reasonably say dilation by a factor of 1/4 in reference to a center of dilation at the origin. If it had not been the origin, it's a little more complicated because you've got to figure out how they changed in reference to what. But these two are just for the origin. So I hope that has helped you on these questions.